differential equation. So variables x and y satisfy the differential equation. Y is 1 when x is 1. So we start by separating the variables, everything with y on one side, everything with x on the other side. We do that by multiplying or dividing by something. In this case, we multiply both sides by dx over y times x plus 1 times 3x plus 1, because we can cancel out on the left, cancel out. So on the left we have only 1 over y dy. On the right we cancel out, we have 1 over x plus 1 times 3x plus 1 dx. So now we integrate both sides. So there's no problem integrating the left hand side. Problem is integrating the right hand side. We cannot integrate this directly, so we're gonna have to use the partial fractions decomposition first. So this is how we do the partial fractions decomposition. The first step is to identify the forms we have to use. For simple linear, we use a constant over x plus 1 here, and another simple linear, so another constant divided by the 3x plus 1. And then we multiply both sides by the denominator. So on the left they cancel out, we have only 1. On the right, when we multiply, we cancel out x plus 1, we have a times 3x plus 1. And when we multiply, we cancel out, we have b times x plus 1. And now we choose the right values of x so that we can get the a and the b as fast as possible. We do that by plugging in the zeros. So here we plug in minus 1. On the left there's no x, there's nothing to plug in, so just rewrite it's 1. And on the right we plug in minus 1, we get 3 times minus 1, which is minus 3, plus 1, which is minus 2. And when we plug in minus 1 here, of course we're gonna get 0. So that's the idea why we should use minus 1, because we want to make this term go to 0. Okay, so we have the value of a now. We plug in something else for b to find the value of b. We can plug in minus 1/3 because that is the 0 of this 3x plus 1. So there's nothing to plug in on the left. On the right we plug in, we get 0. And from here we plug in minus 1/3, we have 2/3, and therefore b is 3/2. So we multiply both sides by 3/2 here. So we have the a and the b. Now we're going to express this 1 over x plus 1 3x plus 1. Here we split it, we use partial fractions, we use a over x plus 1, b over 3x plus 1, we know the a and the b. Okay, now we can integrate everything. We use the I didn't put it here, but we use the integral of 1 over x equals ln x. That's the MF19 formula. So the integral of 1 over is ln. On the left we have ln y. On the right we have again ln divided by 1, because actually there's a 1x here, so just divide by 1 because of this one. And for this integration, again ln the denominator, but divided by 3 because of this 3. And don't forget the constant of integration. So now we can simplify. This is minus 1/2 ln, and 3 divided by 3 is 1, so just 1/2 ln. And we can move this 1/2 into the argument of the logarithm, so we have to the power of 1/2. Same thing here. So we have to the power of 1/2 to the power of 1/2. To the power of 1/2 means square root. And now we have a subtraction. ln a minus ln b is ln a over b. We combine the logarithms, and now we can plug in the boundary condition. So when the y is 1, x equals 1, replace the y and the x, and we can find the value of c. So ln 1 is 0, and if we plug in 1 here, we have root 4, which is 2, and this is root 2. So 4 over root 2 is root 2. Just use your calculator, you get root 2 here, and therefore the c is minus ln root 2. So just rewrite this equation, but the c is minus ln root 2. This is called the general solution, still with c. This is the particular solution, no longer with c. Now find the exact value of y when x equals 3. So we just plug in x equals 3, and find the value of y, so solve for y. So 3 times 3 is 9 plus 1 is 10, and this is 4, so we have 10 over 4. And subtraction, we combine into a division, so we combine this subtraction into a division in one logarithm. Use a calculator for this part. You will get the square root of 5 over 2. So we do e to the power of, they all cancel out, so we have only y equals root 5 over 2, which is the final answer. Alright, I'll see you guys.